Okay, so welcome to Derivative a Day, and today we've got another problem. So in yesterday's video, I explained why and how you can use these videos to your benefit. And today I'm going to bring you another derivative that we can do using the same concept we touched on yesterday, using the power rule when it comes to derivatives. So today's problem, we have a function of time, the position of whatever, some object like a car. That car, however, wouldn't be moving, otherwise we'd be using displacement. But 14t cubed, that statement there didn't really matter, by the way, so if you didn't understand it, don't worry. 14t squared plus 14 minus 14. Okay, so 14t cubed minus 14t squared plus 14t minus 14. So, as discussed yesterday, and I'm just going to change the color, let's go green. It's a bit too similar. Oh yeah. As we discussed yesterday, if we have a function of some variable, in this case it's x, that's equal to a being some number out the front, x being the unknown, and n being the exponent. We can then take the derivative of that function using the power rule, which is defined as, so a times by n. So n comes down and we multiply a and n together. We keep the unknown there, and then what happens to our exponent, n, is we subtract 1 from it. And once again, we're going to apply this rule here to solve this problem. Let's try and match that same color. So the derivative of our function pt will now equal 14 times by 3, as the 3 comes down, and since it's a function of t, we put t there. Now the 3 up here, we go 3 minus 1. And in your head when doing this, the reason why it's good to practice this is you don't need to write this step down. This is just for practice here. You don't write the 3 minus 1, you just skip the step and just go straight to 2. You'd write, 42t squared. And unless you want to and it helps, then for sure do that. Now here, remember, there's always a magical 1 sitting above this t. If there's a t or an unknown variable without an exponent, there's always a little 1 there. So we bring the 1 down, 14 times by 1 t, and then it is our 1 minus 0, which will, in the next line, get rid of our t here because it's t to the power of 0, which I believe is just 1. Based off the exponent rule. So 14 times 3 is 42. Now we need t, and 3 minus 1 is squared is 2. Now we've got 14. What happened here? Oh, I didn't write the 1, so we multiply that by 1. Anyways, so that's just 14. Now 2 minus 1 is 1. However, let's not write that today. We're just going to write 14t plus, now 14 times by 1 is obviously 14. However, since t is now to the power of 0, it's like we're timesing 14 times by 1 again. So using the exponent rule, any unknown to the power of 0 will just equal 1. And that's where we get that from. Ooh, that was a bit messy. So instead of writing 14 times 1 here, we can just not write the 1 and just write 14. And that is the answer. So hopefully you got the same. If not, that's all right. Tomorrow we'll do just one more that's like this question. I'll try and make it a bit more complicated. However, this now be summarized as PT dash, or another way to write this actually is dp. So the change d, if you've done physics, you'd be quite familiar with this. I forget what it's called. I don't think it's sigma, but it's just, this stands for the change. So in maths, we just use a d. So it's dp, the change in p, over the change in time, or t, will now equal 42t squared minus 14t plus 14. That's our answer. So hope you have a good day, and I'll catch you tomorrow for another question.